There you are, Dottie. Look right up where I'm pointing on the mountainside. That's the Great Stone Face.
Oh, I see it, Daddy. I see it. It looks just like Grandma, doesn't it, huh?
Where did you get that idea? Of course it doesn't look like Grandma. The mouth is nothing like hers.
Oh, but the nose is. There's even a wart on the side of it, see?
That's just a piece of brown rock.
Ah.
You mustn't compare a hunk of granite with your sweet old Grandma, Dottie.
Mustn't I?
Of course not.
Oh.
What would she say if she ever heard you?
Oh, she wouldn't like it, would she, Daddy?
She certainly would not.
No. Is flint a stone, Daddy?
That's a funny question. Yes, I suppose flint is a stone.
Then why are you bawling me out, Daddy? I heard what you said about Grandma last week.
What are you talking about? What did I say about Grandma?
It was when she wouldn't lend you that money. You read her letter, and then you said to Mommy, "What do you think of that old skinflint? She's got a heart of stone."
There goes Dottie again, putting her little foot in it. But I wouldn't say the fault was all hers. Daddy should always remember that little pitchers have big ears. And speaking of ears, I trust there are a goodly number tuned in to absorb the fascinating information we've compiled for today's program, A Piece of Stone. A glance out of the corner of my eye reveals that our science reporter Al Zink is standing by to do his customary honors. So we take pleasure in bringing you another Excursion in Science.
Thank you, Bob Stone, and how do you do, everyone? The facts we are about to bring out were supplied to us by Mr. P. Schuyler Miller, Assistant, Schenectady Museum, and Secretary, Van Epps Hartley Chapter, New York State Archaeological Association.
Well, Mr. Miller sounds as if you're ably qualified to cope with the subject, Al. But what, may I ask, is that sinister-looking object reposing near your right hand? Could it be a rock, perchance?
Yes, Bob, it's a piece of stone, but I intend to use it only to peaceful purpose. Let's examine it. I'd say it's about, 4 inches long, maybe 3/4 of an inch thick. It varies from 2 1/4 inches wide at the broader end to about 1 3/4 inches at the narrower end. Weighs a little less than 8 ounces, and it's grayish-brown in color with a variety of brown and black markings. All in all, a very ordinary piece of stone.
Quite a proficient analysis, Al. But where does all this leave us? We haven't yet been reduced to breaking rocks for a living.
Quite true, Bob, but if you will recall, the great Huxley started his adventure in science with a piece of chalk from a carpenter's pocket. Our piece of stone came out of a farmer's pocket, probably not so many years after Huxley told his story of chalk back in 1868.
Whatever made this farmer you speak of salvage the stone in the first place?
Well, Bob, let's imagine a descendant of one of the old Dutch pioneers of our own Mohawk Valley, plowing the fertile bottomlands along the stream on a fine spring day. Suddenly his plowshare turns up this piece of brown stone, or perhaps he failed to notice it until the field had been harrowed and the spring rains had begun to rinse away the clods of dirt. At any rate, there came a day when something about the stone attracted his attention, and he picked it up and carried it home. There it began the journey which ends beside the microphone here today.
I still can't see the contribution this inanimate object will make to our program unless you're going to tell us those brown streaks are gold.
Nothing like that, Bob. But a geologist could read in this stone the whole history of our planet. He would study it under a microscope and see that it is what is roughly termed a kind of greenstone, fine-grained, full of tiny crystals of quartz, garnet, and other minerals. He would examine a place where the plow has chipped away a bit of the surface and see that the stone has a kind of thin brownish crust covering it.
Well, what does that indicate, Al?
That the stone has been in the ground for a long time, long enough at least so that the natural chemical action of the soil has changed the structure of the stone. If he were a physical chemist, he might begin a laboratory study of the way in which this patina, as it is called, is formed, and eventually arrive at some estimate of how long the stone lay in the earth.
Well, don't keep me in suspense, Al. You're beginning to get me stone conscious.
A geologist would certainly notice, too, that the stone has lumpy-looking veins of rusty-colored mineral running through it, which would tell him that it contains some form of iron. By making a chemical analysis of these spots, or by cutting a very thin section out of the stone and placing it under a petrographic microscope, He could probably say exactly what this iron mineral is and how it got into the stone. From these facts, he could tell us how the stone was formed and hazard a guess as to where it originally came from. Also, how many millions of years ago it was created from the elemental chemicals of the Earth's crust.
Quite astounding, Al, but surely our farmer friend didn't discern all these facts when he picked up the stone.
Certainly not, Bob. Our farmer didn't regard it as a geological specimen. His field was probably full of stones, and generally if he picked one up it was only to get it out of the way of his plow. This particular stone attracted his attention for other reasons.
And those reasons are?
Well, let's look at it again. A rectangular block of brownish stone, just big enough to fit into the palm of your hand. It's smooth, almost greasy. The edges are rounded and the narrow end seems battered. Here and there on its surface are patches of light-colored pits, as though something had been pecking at it.
A pterodactyl, no doubt?
Well, hardly, Bob. I want you to pick up this stone, turn it over, and you'll see what the farmer saw.
Well, I see that the broad end is hollowed out like an old-fashioned sugar scoop and has a sort of beveled edge.
Very observing. You'll notice there are peck marks all over this side, too. When you hold the stone up so the light strikes slantingly across it, you can see hundreds of scratches, long and short, fine and coarse, running across the surface. Now, a farmer of 70 or 80 years ago would have recognized that here in stone he had a crude replica of one of the steel gouges from his own tool chest.
I begin to understand. This stone, then, is an Indian relic.
Quite right, Bob. It is undoubtedly a gouge used by the Indians for woodworking, such as hollowing out a log to make a dugout canoe.
Well, how is the thing manipulated? Modern gouges are set in wooden handles, and the user taps the butt with a mallet to shave off bits of wood. The stone gouge has no handle.
No, but of course the wood may have rotted away. However, let's examine it further. You'll note the whole surface has a soft, velvety texture, almost a greasy feeling. Such an effect might be produced by the rubbing of a calloused palm, a greasy palm perhaps, over a long period of time. The polish is deepest across the back, on the sides, and at the base of the groove, as if it had been held in the workman's hand, lying across the palm, with one side tucked into the notch between his thumb and forefinger, his fingers curling around the other side, and his thumb resting on top.
You make it very graphic, Al. What would you say is the explanation for those chips at the narrow butt end of the tool?
Well, Bob, those chips are exactly what might be expected if our canoe maker had held the gouge with the bit down and hammered the blunt end with another stone, just as a carpenter hammers the butt of his steel gouge today.
Well, that seems reasonable. But how come those little whitish pits over the surface of the stone?
If you've ever hammered one stone against another, Bob, you'll remember that just such little spots of whitish powdered crystals are formed where the two stones hit. In time, those crystals would be washed or rubbed away, leaving just such pits as we see here. In all probability, then, this gouge was battered into shape with some sort of stone hammer. As to the scratches running up and down the length of the groove, we can assume that they were probably made as the ancient toolmaker sharpened his roughly shaped gouge with a piece of coarse sandstone and gave it a final smoothing with a hone of finer material. So you see, Bob, what a vivid story we can construct from this mute piece of stone.
Indeed, yes, Al. I'll never be inclined to use another rock for a paperweight.
From relics such as this, we may gain much additional information. We begin to understand the pattern of daily life led by these ancient people. We find knives and half-moon-shaped choppers of ground and polished slate, almost identical with those made by the Eskimo. And we deduce that if these folk were not themselves Eskimo, they must at least have been neighbors of that Arctic people. Today the archeologist begins where Huxley ended, with the coming of mankind. And from the pieces of stone men have used and thrown away, he reads a story of the evolution of society through the ages.
And a very fascinating story it is, Al. Thank you for telling it to us, and many thanks also to Mr. Miller for the scientific data he supplied. And ladies and gentlemen, if you would like to have a copy of a paper by P. Schuyler Miller, Assistant Schenectady Museum, and Secretary, Van Epps Hartley Chapter, New York State Archaeological Association, a paper which will give you a resume of the information you have just heard, with additional interesting facts, all you have to do is address a penny postcard to Excursions in Science in care of the station to which you are now listening, asking for scientific paper number 244, entitled A Piece of Stone. That's scientific paper number 244, A Piece of Stone. Your copy will be put in the mail for you free of charge. And now we come to that portion of our program designated as question and answer time, during which scientific questions will be answered which have been sent in by you listeners. The answers reflect the most up-to-date and accurate information available, since they are based on facts provided by staff members of the General Electric Research Laboratory or other equally trustworthy institutions. Well, I trust you will bring the same masterful analysis to bear upon these questions as you did on that piece of stone.
I'll do my best, Bob.
Our first puzzler comes from a male listener who asks, is there any process known to science whereby iron, which is wasted away in the form of rust, can be returned to its original form?
There is no natural process by which iron rust returns to iron, Bob, although by chemical means it can be restored. In fact, in a sense, iron ore might be considered a form of iron rust. The process of refining the ore might be considered a way of restoring iron rust to iron.
So far, good. Now let's see what you can do with this one. How do astronomers figure that the universe is moving, and why don't we occupy the same space as we did last year?
The question about how astronomers figure that the universe is moving is not quite clear. The universe includes the whole of creation, and so it cannot be moving in the sense of shifting from one position to another. However, we sometimes talk about the expanding universe. By analyzing the light from distant stars or nebulae by means of the spectroscope, it is possible to tell not only their composition, but also whether they are moving towards us or away. When motion is towards us, the dark lines shown by the spectroscope shift from normal position to the blue end. When a star is moving away, they shift towards the red end.
But how about the expanding universe? Does that only occur when inflation sets in?
No, Bob, it has no economic significance. Our whole Milky Way system of stars, called the galaxy, is only one of billions of galaxies which are within reach of large telescopes. It has been found that the farther away these are, the more the lines in their spectra are shifted to the red. This would seem to indicate that the more distant galaxies are moving away from us with greater and greater rapidity. As one explanation of this, it has been suggested that the universe is expanding, that once the galaxies were close together, and then something happened and they started spreading out. Under these conditions, an observer on any one of them would observe that the others were moving away, so this does not mean we are at the center. However, the idea of the expanding universe has not been proved, and other explanations of the red shift have been offered.
I could ask you about these other explanations, but our time's limited, Al. I have another heavenly subject at hand. A lady in Massachusetts inquires, what would cause a short vertical rainbow in the south? She goes on to say this occurred in the afternoon when the air was clear, cold, and frosty.
The rainbow always appears in the part of the sky opposite the sun and is caused by the bending of light rays in water droplets. What was seen was evidently not a rainbow, since it was in the direction of the sun. It was probably some form of halo caused by the bending of light by ice crystals high in the air. Sometimes these are very marked and show brilliant colors.
Al, 2 listeners have written in asking how a divining rod works. I'd like to find that out myself. They're mysterious things.
There is no scientific explanation of the so-called divining rod, Bob, and there is considerable question and skepticism on the part of scientists as to any worth whatsoever in this device. Very reasonable and logical explanations can be given to explain the movement of the divining rod, which have nothing whatever to do with underlying water or metal. It may be due to the fact that the rod is held in an unstable position, and it tends to move to a more normal position after it has received sufficient pressure to cause it to flip over.
Our next inquiry comes from Denver, Colorado, and has to do with plant life. This gentleman asks, what is the force that pushes or pulls the soft buds of the crocus up through dry, hard-packed soil in spite of gravitation?
Well, Bob, all living plants have a kind of attraction for water, which they usually can get from the wet earth by means of tiny rootlets. The water enters because of dissolved matter, such as sugar and salts, which is already present in the sap. This tendency of the water to enter the plant is called osmotic pressure, and is more forceful than the drive of water to wet a dry sponge, for example. This pressure extends through all the cells of the plant, similar to the blood in our system. It is that which forces the plant to stand erect and even grow taller. If this extra water pressure is absent, the plant will wither and die.
Well, let's see if we can't slip in a quickie, Al. A young lady asks, can something be burned without oxygen?
Yes, Bob, burning does not necessarily require oxygen. For example, magnesium or aluminum can be burned in nitrogen or chlorine gas. Burning has a more general meaning, too, such as we say a lamp bulb burns.
And control operators burn, too, unless we get off on time, so I'll just say thank you, Al Zink, and goodbye, everyone, until our next excursion in science.